Have you ever wondered if the universe is merely a symphony of strings vibrating in dimensions we can't perceive? Welcome to the enigma that is string theory. This intriguing concept isn't your typical theory. You see, string theory isn't just about the three dimensions we're familiar with: up and down, left and right, forward and backward. It's a mathematical framework that suggests the existence of even more dimensions. Imagine a world beyond the three-dimensional one we experience daily. These additional dimensions are theorized to be so minuscule, so incredibly tiny, that they're beyond our perception. Now, it isn't just about their existence, but also about their shape. These dimensions can take on various forms, each influencing the universe and subatomic particles in different ways. From the properties of the cosmos to the behavior of the tiniest particles, these extra dimensions could potentially have a say in it all. So, despite the criticism, string theory still holds a glimmer of hope for many physicists. But why? In the 80s and 90s, string theory was a beacon of hope, promising to unify fundamental forces and integrate gravity into quantum theory. Yet it fell short. The criticism was harsh and swift, with detractors pointing out that string theory was not living up to its grand promises. There was a sense of disillusionment as the framework, once heralded as the key to understanding our universe, struggled to provide the anticipated breakthroughs. But let's not forget the dedicated group of physicists who have never given up. They've been tirelessly working, exploring different geometries of the extra dimensions in string theory. Their aim is not only to address the unresolved questions in particle physics and cosmology, but also to breathe new life into this mathematical framework. They believe that string theory still holds the potential to explain the shortcomings of the standard model of particle physics, like the absence of gravity and the inability to explain dark matter and dark energy. So what keeps these physicists going? It's the unanswered questions that string theory might just be able to solve. String theory, despite its shortcomings, might hold the key to some of the biggest mysteries in particle physics and cosmology. Let's delve into how string theory could potentially address the limitations of the standard model of particle physics. This model, though robust, has a glaring omission. It doesn't include gravity. Now, gravity is a fundamental force of the universe, so its absence in the model is a bit like having a puzzle with a missing piece. String theory could be the missing piece. It proposes that everything in the universe, including gravity, is made up of tiny vibrating strings of energy. But the potential of string theory doesn't stop at gravity. It might also help us understand dark matter and dark energy, two enigmatic phenomena that the standard model can't explain. Dark matter is believed to make up about a quarter of the universe, and dark energy about 70%. Yet, we know very little about them. Could they also be composed of these theoretical strings? It's a question that string theory might help us answer. Now let's talk about the extra dimensions in string theory. We live in a universe with three spatial dimensions and one time dimension. But string theory suggests there might be more dimensions, too small to be noticed. By exploring different geometries of these extra dimensions, researchers hope to find a comprehensive framework that encompasses all known phenomena in the universe. The potential implications of this are mind-boggling. Could we one day be able to understand the universe in a way that we never thought possible? Despite the criticism, string theory is not dead. It remains a vibrant field of research, humming with potential and promise, much like the theoretical strings it proposes.